Hello everyone, this is Shivam Mehta, pursuing Masters in Construction Engineering and Management from SEPT University, Ahmedabad. So currently I am in my fourth semester. So we have directed research project in which my topic is Lean-led improved design process in healthcare project. So introduction as well as the research gap. So the introduction is like Lean is a methodology offers a streamlined approach to improve the process and helps to understand it and increase the efficiency in healthcare design. So by implementing the lean tools such as value stream mapping, VSM, and choosing by advantage, CBA, in which the architect can gain invaluable insight to into the current state map, into the design process in which they can identify the improvement areas as well as they can make few key decisions to improve the design solutions. So the aim is to conduct an action research study for the lean-led design process in healthcare. The main objectives are to analyze the current design process of the healthcare in which by using the lean tool to identify the waste and eliminate it from the design process, to implement the lean tools in a particular context and analyze the challenges, results and benefits of its implementations. So the challenges in healthcare designs are budgetary constraints, technical integrations, sustainable design, and communication gap between the stakeholders. So, as earlier mentioned in introduction, the lean tools will be used are value stream mapping and choosing by advantage. The scope. What will be the scope? The scope, it studies how using lean principles in healthcare design can make a project better. It explores tools like VSM and CBA. The study also checks how picking the right tool and working together with everyone involved can make project efficient and valuable. So now we'll see the research methodology. So first of all, for diagnosis, and the first thing was done literature review, in which uh, the vast literature was done, like first done for construction, then lean design, lean healthcare, uh, project-based VSM, and CBA. Then after doing the literature, we went for action planning, which says of data collection, in which understanding the whole design process, then observing the process, then questionnaire, then interview with the stakeholders and experts. Then after done the data collection, then we went for action taking, which we can say it as data analysis. So there are two different paths for VSM and CBA. For VSM, it's applying value stream mapping in design process, then current state map, then identifying the waste, then future state map by using a lean tool to recommend improve with respect to waste identified. Now for CBA, applying choosing by advantage in design process, identifying the decision alternatives, define factors, criteria and attributes, then determine the importance of IOA and compute the total of IOA for each alternative, then evaluate cost versus IOA. Then last, the learning and conclusion, in which evaluation of the collaboration analysis reflecting on its learning. So now we'll see the need of study. It is like the clarity of the scope at every design stage, identify the most optimum time taken in value adding activities, then eliminating the waste. It leads to improvise the flow and client satisfaction while saving the cost. Now we'll see literature review. So as discussed in methodology, so these are the uh, inbuilds of literature review, like how what things were done. So in lean construction, the output was the maximize the value and minimize the waste in the process. So and the 8 types of waste were categorized, then different stages of construction. In lean design the outcome was like understanding the how to apply lean principles to a design process, then emphasizing the collaboration, simplicity and value creation in it. Then in lean healthcare and focusing on the eliminating the waste, reducing errors, and enhancing the quality of care, and identifying of key success factors and challenges that are faced in lean construction, or we can say in healthcare, as well as in project-based VSM. The outcome were enhanced understanding of VSM application in project-based, then insights into VSM impacting on the project efficiency, and then framework for implementing and recommendation for optimizing the VSM. In CBA, the outcome is decision-making framework for prioritizing the initiatives, then assessing the option based on strategic alignment and potential benefits. So these are the types of ways, the 8 types of it: the downtime, defect, overproduction, waiting time, non-utilized talent, extra time, motion, inventory, and transport. Now we'll go through the stages of design. So the stages were design of concept design phase, schematic, detailed design, and GFC stage. The key points, we can say, the stakeholder collaboration, patent center design, decision making, as well as the continuous training and development for the process. Now for the action planning, the data collection, we did selected the two private projects. The first is the Cancel and Opal Center in Ahmedabad with 2.5 lakh square feet of area with ground, basement, and 13th floor. The project, when we selected, the project was in schematic stage, and currently this project was in GFC stage. And now we see the project 2, it is a Urology Transplant and Research Center in Nadiad with 4.5 lakh square feet with basement, ground floor, and uh, 5 floors. During the selection, it was on design development stage, and it is currently in approval stage for design development. Now we'll see how the data collection was done. The first of all, the understanding the process, the analysis of process, stages, tasks, and responsibilities were done. Then preparation of swimline diagram was done for visual representation. Then development of schedule based on swimline, then observation, like highlighting the key observation from the process, identifying the ways that can be reduced or eliminated, then noting of any challenges or bottlenecks in that process. Then we see about the questionnaire, 24 question based on the literature review and process where under the understanding was prepared. Then questionnaires covers the various aspects related to design design process. Then interviews, then interviewing with professionals associated with the design process, and interviewing the stakeholders associated with the design process as well. Now we'll see the data collection for value stream mapping, how it took place. So this is the first of all analysis of data. So based on submission schedules, as you can see in the down, there are submission dates of project one, then drawings, time data sheets, transmittal, and record of communication. The way when they send back to and fro was there. Then applying value stream mapping, mapping out the current flow to visualize the process step, cycle time, and insufficiencies. Then current state mapping, creation of visual representation of the current design process. Then identifying the waste while conducting the stakeholder interviews, current state map analysis, and waste identified in downtime. In this way, the identifying waste was done. For future state map, by using the utilizing the lean tools, designed uh, future state map, eliminating the waste, optimizing the workflow, and improve efficiency and productivity. So now we'll see the how the data was analyzed. So this is the submission dates of for project one. So in this, as you can see, the revision was on 15th of November. First revision, second was on 30 of November. Then the final issue date of is 11th of Jan 2024. As you can see, this is a small part of the schedule of activities, the schedule that was prepared based on that. As you can see, on 15th of November, they have prepared the R1 preparation of workflow plans of section and elevation was done, as it is matching on schematic design, and this is also of schematic. So on based on that, the whole schedule was prepared. So the inferences, submission dates for project one, guided activities, scheduling, and the process time determined The facility the prepared of schedule aligning tasks and deadlines, verifying the dates against the schedule, enable the efficient time management and the tracking of project. So now we'll see action taken for value stream mapping, or we can say data analysis after the data collection. So now you can see that this is a value stream map. It is a snapshot, a short process in which I'm trying to explain how the value stream map looks like. So as you can see, the first is presentation review from the client. So this part, as you can see, the part in light blue is process time, and the part in gray is the total lead time of that activity. So based on this value stream mapping, uh, based on its design phases, the process is divided. Like you can see, the concept design phase in current state map, the total lead time is 35 and the process time is 28.90. Same as you go to the schematic design, the lead time is 60 and the process time is just 34.167. Same for DBR stage is 44 lead time and the process time is 38.44. Same goes for tendering stage, or we can know the detail design stage, and for GFC stage. So based on this, on all every phases, based on entering the stakeholders and the people uh, who are interlinked with the design process, uh, entering it, getting to know about the what are the value adding, non-value adding activities. So, based on classification, non-value adding activities were pinpoint, in which the non-value adding was 41.47% of total time, in which 58.53% was spent on value adding tasks, in which non-value adding but necessary was 26.58%, and non-value adding but not necessary was 14.89%. So this is undergoes to reduce the, or we can say remove the waste task to enhance the process efficiency. So now we'll see the total waste based on this non-value adding activities, what way the waste categorized in it. So to analysis the various the category of waste was done, including the defect was 2.92%, motion was 6.63, overproduction was 21.45, and inventory was 22.24%, and waiting time, which was a maximum, is 55.87%. The waiting accounts for the highest portion of the waste due to the delays in obtaining the approvals and information from kind, as well as the hierarchy. So based on the types of waste, as there is a snapshot here of the how it was done. So like this is the R1, in which the total actual process time was 5, but it could be 0.4.5 as there was a waiting and comments from approval from the principal architect. Same we go for the second, it was a waiting time from the principal architect. Here it is a waiting time from the client, as this it is a defect in the revision of the drawing, as you can see in WBS 1.2.1.1.5, in which there was a rearrangement of OPD. So the total actual process time was 2.31, but it could be possible in 1.85 days, as there was a lack of review and drafting in which the defect was there. And as we can see in revision 2, there was an overproduction. The overproduction was done in incorporating the ARB in place of the nuclear. So in this also, the 1.6 actual process, the possible it could be in 0.6. This is a snapshot of an future state map, in which as you can see this is a Kanban, in which the lean tool is been used and how to optimize it. So based on that, as you can see in concept design phase, the try to reduce the lead time as well as the process time, and we are improvising it based on that. So the utilizing the value stream mapping in project one proved that that a difference between the value adding and non-value activities lead to an reduction of 24% of total lead time in the design process. So with this implementation of current state map implementation, the process change including improvements in the value stream mapping and future state mapping, and minimizing the waste obtained where like cause of waste were choosing a change in scope or design in electrical services, design changes, unnecessary information sharing of drawings, incomplete staff, and creating of database that could reduce the waste chances in it. That also helps to improve the efforts and collaborative problem solution to optimize the project um, value as well as uh, achieve the project efficiency. Now we'll see action taking for choosing by advantage. CBA is a decision making system that supports sound decision making using comparison among the advantages of alternative. So the first step was identify the alternative, then define the factors, define must and want criteria, summarize the attribute of each alternative, decide the advantage, decide the improve of each advantage, then evaluate the data. For this CBA, we have taken types of wall covering. The first is antibacterial antifungal paint, then vinyl wall covering, then leaning cuddling walls. So based on this, the identification of factors from each stakeholders were listed down, like should be durable, should be aesthetic, and so on. For designers, it antibacterial, antifungal, chemical resistant, easy to clean, project timeline, maintenance, and etc. For contractors, size, availability of material, finishing, warranty. And when we talk about the facility operators, maintenance, curved joint, thermal conductivity, waste management, and recycle, based on whole this thing, and every stakeholder was sat, and based on that the must and want factors were listed down. So the must and want factors are, the must factors we'll see first. It's like antibacterial and antifungal, chemical resistant, impact resistant, infection control, efficiency, warranty, durability, aesthetics, finish, and environmental impact. And want where maintenance, waste management, and recycle, easy of cleaning, regulatory compliance, and project timeline. So based on must and want factors, the CPI attribute table for comparison is done. So here we have shown just three factors and its criteria based on what has been done. So the first is antibacterial and antifungal. So here the paint is just 25% efficient on it, as it has a silver ion technology. Where and vinyl wall covering has more than 99.9%, and it has been put on by ISO 22196. It's a test done by the company, and it shows it's 99.9% inhabitant. And for leaning cuddling wall, it's 99%, which has been copied from ISO 864 3, in which the vinyl wall covering is 100%, as has the maximum attribute. And this the marking system is given by the stakeholders based on its advantage and its attributes. So for that, the chemical resistance, and you can see the highest it's is linen cuddling wall for 98%, and followed by vinyl, it's 95%. And here it depends on the material and maintenance. And based on this attribute table, the highest score was by vinyl wall covering, it's 1270, followed by leaning cuddling wall, it's 1210, and the last is antibacterial antifungal with 65 645. Based on, now we have just compared IOA versus cost. So based on this, as you can see, the highest is uh, vinyl wall covering, which is 1270, but it has an highest rate of 115 rupees per square feet. Using this graph shown, the cost of each alternative may be determined while accounting for that associated advantage score. While antibacterial and antifungal has a lowest score, but vinyl wall covering delivers superior performance characteristics, certainly for healthcare projects, and also the overall IOS score of vinyl wall covering is higher. So considering both the factor, conclusion for CBA study of the problem is that vinyl wall covering is more suitable for healthcare projects. Conclusion, that action research was carried out for employing the lean methodologies uh, like value stream mapping and CPA into healthcare projects, showcasing their efficiency for refining design process and decision making. So VSM proved in identifying and addressing the insufficiency in the healthcare design process by analyzing the current state map and targeted improvement significance reduced in lead time were achieved, enhanced the project efficiency. Collaborative approach and suggested adjustment lead to decrease the lead time, streamline the process, and enhance the collaboration among the stakeholders, as well as the comparison between the projects highlighted a common challenges such as waiting time, defect, and inventory waste, emphasize the need for ongoing process optimization and continuous improvement to achieve better outcome in the future healthcare projects. So now CBA played a very virtual role in selecting the ideal wall covering for hospital design process, with vinyl emerging as a top choice despite its cost is little higher, but the stakeholder engagement was key, ensuring information decision and enhance decision outcome. This integration focused improve interaction, highlighting the importance of collaborative decision making in healthcare design. So now we'll see the research limitations. Like there was a little bit access of data regarding the healthcare, and there were short timeline was there, time limitation of this whole DRP, and there was one more limitation like one project per organization was studied. It could be like multi-project rather doing it would be more. And now we can see like the what is the future scope of this, like multiple projects of the same organization can be compared or considering any one phase. Like in this I've studied the whole process of design, in which in future you can stick to any one, like in concept, or it can be schematic or detailed design phase. There are more opportunities in schematic and detailed design phase. It has stung of drawings and all, so that could be studied in further. Thank you.